picture this. You've planned like the absolute perfect day out.
Oh, I know where this is going.
Right. So you're on a trail, the scenery is just stunning, the air is crisp, and you are completely in the zone.
Yeah, the ideal hiking scenario.
Exactly. And then out of nowhere, the sky turns this really menacing shade of gray.
And it all falls apart.
Yeah, before you can even reach your pack, the heavens just open up. A total unexpected downpour.
Yeah.
Within minutes, you are soaked to the bone, you're shivering, and suddenly that beautiful hike feels like a pretty miserable, maybe even slightly dangerous slog back to the car.
I mean, we have all been there. It is the universal outdoor experience, really.
It really is.
Nature has a funny way of completely ignoring our itineraries.
It does. But, your gear shouldn't. And that is exactly what we are getting into today for this deep dive.
Oh, absolutely.
We're looking at a huge stack of sources, including this really comprehensive 2026 gear guide. It's called Waterproof Tech, the best rain jackets for hikers.
It's a great piece of content. Lots of technical details in there.
Yeah, so our mission here is simple. We're going to cut right through all the dense marketing jargon of outdoor apparel, decipher how this modern technology actually works under the hood, and arm you with the exact knowledge you need to choose the perfect gear for literally whatever nature throws your way.
Because, a rain jacket in 2026 is no longer just a piece of clothing you throw over your shoulders.
Right.
When you step into the wild, it functions as a vital piece of survival equipment.
Wow, survival equipment.
Honestly, yes. Its primary job is to regulate your core body temperature and prevent potentially dangerous conditions like hypothermia from setting in when the weather suddenly turns hostile.
Yeah.
It operates as the literal barrier between you and the elements.
Okay, let's unpack this. Because to really understand how to buy the right jacket, we have to start at the microscopic level.
We do.
We are dealing with a fundamental paradox here. The jacket has to act like a brick wall against the pouring rain, but at the exact same time, it has to act like an open window for your sweat.
Exactly. It's essentially trying to enforce a one-way street for moisture, which is just a massive engineering challenge.
I can imagine.
The core functionality of a modern waterproof membrane is built entirely around solving that specific paradox. I mean, think about it. If you are hiking, you are exerting energy.
Right, you're working hard.
You generate internal heat, and your body's natural cooling mechanism is to sweat to bring that core temperature down.
Which is fine normally.
Right. But if that sweat cannot escape, the relative humidity inside your jacket just skyrockets, and the sweat builds up right on your skin.
Wearing a completely non-breathable raincoat is like hiking inside a plastic trash bag.
That is the perfect way to describe it.
Sure, the rain doesn't get in from the outside, but you end up entirely soaked from your own sweat anyway. You get that clammy, sticky feeling.
Well, it's the worst.
And the second you stop moving and the wind hits you, you freeze.
What's fascinating here is how advanced breathable materials solve that trash bag problem. It all comes down to the sheer physics of molecular size.
Wait, molecular size, like the size of the actual water droplets.
Exactly. These synthetic membranes are engineered with microscopic pores. We're talking about pores that are thousands of times smaller than a single drop of liquid rain.
Oh, wow. So they're incredibly tiny.
Right. So when heavy rain hits the outside of the jacket, the liquid water physically cannot pass through the barrier. It is far too large.
It just bounces off.
Essentially, yeah. But water vapor, which is what your sweat becomes as it evaporates off your skin, that's composed of independent molecules that are vastly smaller than liquid water droplets.
So the vapor molecules are tiny enough to just slip right through the pores, escaping out into the air, while the massive raindrops are locked out.
You got it.
That makes a lot of sense.
Right.
And blocking the wind plays into this too, right?
Oh, definitely.
Because you need to keep the freezing air from stripping away the tiny bit of warm air your body has generated.
Yeah, the membrane stops the wind from physically cutting through the fabric and disrupting that internal microclimate.
So it's doing double duty.
It is a constant, delicate balance of blocking external moisture and wind while actively utilizing the heat your body generates to push sweat vapor out through those microscopic pores.
That is so cool.
That specific mechanism is really what defines modern outdoor gear.
Now that we know what the membrane is actually doing, let's talk about how we measure its performance. Because, if you shop for a jacket, you see these giant numbers on the tags.
Oh, yeah, they're everywhere.
Like 5,000, 10,000, 20,000, and it can be incredibly confusing to figure out what you actually need.
These are the hydrostatic head ratings, right?
Yes. The hydrostatic head rating is the industry standard laboratory test for waterproofness.
Okay, how does that work?
Imagine a 1-inch by 1-inch vertical tube resting flush against the jacket's fabric.
Okay, just a tall tube on the fabric.
Right. In the lab, they fill that tube with water, and they just observe how high the water column can get measured in millimeters before the sheer gravitational pressure forces the water to leak through the fabric. Oh, I see. So a 10,000 millimeter rating means the fabric can withstand a column of water 10 meters high before it leaks.
Exactly.
That is a lot of pressure.
Yeah.
So looking at the market breakdown in our sources, a 5,000 millimeter rating seems to be the baseline for light rain protection.
Yes, very basic protection.
Then 10,000 millimeters covers moderate hiking conditions. 15,000 and up is recommended for serious trekking. And then you have the 20,000 millimeter plus category for like heavy monsoons and extreme weather.
This is the general scale, yeah.
But let me push back on this for a second.
Sure.
Does a higher number automatically mean a better jacket for every single situation? I mean, if I am just doing a casual weekend trail, isn't a 20,000 millimeter rating totally overkill? And maybe heavier?
It usually is complete overkill. A higher number does not universally mean better.
Really?
Yeah, it just means more impenetrable, which comes with a massive trade-off.
Ah, the catch.
The thicker and more robust you make that membrane to handle 20,000 millimeters of water pressure, the harder it becomes for your sweat vapor to push its way out. You inherently sacrifice breathability.
Oh, so you might be protected from a monsoon, but if you're sweating hard on a mild, slightly damp day, you're right back to feeling like you're in a trash bag.
Exactly right. To withstand that extreme pressure, manufacturers often have to use what's called a three-layer construction.
Okay, what does that mean?
It means they are bonding a heavy outer fabric, the thick membrane, and an inner protective lining all together into one piece.
That sounds bulky.
It is. This makes the jacket much stiffer, significantly heavier, and usually a lot more expensive.
So what's the alternative?
Well, if your goal is just a light afternoon hike in the foothills where you might encounter, a passing drizzle,
Right, just normal weekend stuff.
then a 5,000 to 10,000 millimeter lightweight shell built with a 2.5-layer construction is going to be infinitely more comfortable,
Because it's thinner.
right? It bends with your body, it breathes easily, and you can usually just pack it away right into its own pocket.
That's super convenient.
The trick is evaluating your actual environment rather than just buying the highest number on the rack.
So basically, match the gear to the mission.
Exactly.
But let's say you do buy that 20,000 millimeter rating for a serious mountain trek. You're invincible, right?
Not exactly.
Right. Well, not if you don't look at how the fabric is actually put together. Because having this incredibly rated fabric but unsealed is like having a solid steel fortress but leaving all the windows wide open.
That analogy hits the nail on the head.
That's just a weak point.
A huge one. Every single place a needle punctures the fabric to stitch the arm to the torso or to attach a pocket creates thousands of tiny holes.
Oh, of course. Needles literally poke holes.
The hydrostatic rating of the fabric means nothing if water just seeps through those thread holes.
So what do they do about that?
Fully sealed or taped seams are a non-negotiable feature for true waterproofness. In the factory, they use heat to apply a specialized waterproof tape over every single internal stitch.
So they're physically blocking those microscopic entry points.
Yes, physically sealing them shut.
Because water will always find the path of least resistance.
Always.
Beyond the seams, there are structural features that actually interact with the breathability we were talking about earlier. For instance, underarm ventilation zippers, pit zips.
Oh, pit zips are essential.
But if the membrane is doing its job and breathing, why do we need giant zippers under our arms?
Because the membrane has a maximum transfer rate.
Oh, like a speed limit for the sweat.
Exactly. Even with the most advanced breathable tech in the world, if you are doing a steep, intense uphill climb with a heavy pack,
You're sweating buckets.
right, you generate heat and sweat much faster than the microscopic pores can process it. You need a manual override.
A manual override. I like that.
Pit zips give you instant temperature regulation. You open them up to dump all that trapped heat rapidly.
And since they're under the arms,
The opening is naturally sheltered from the rain falling from above. You vent the heat without exposing your core to the storm.
they are absolute lifesavers. I will literally never buy a hiking jacket without them.
Smart move.
And another crucial structural choice is how the jacket integrates with your overall wardrobe. I mean, if I'm shopping, I basically see 3 categories on the rack: lightweight shells, Heavy-duty shells and these bulky 3-in-1 jackets.
Yes, the classic 3-in-1.
Why are the 3-in-1s so popular if they are inherently heavier?
Because they solve a fundamental problem of outdoor layering in a single package.
Okay.
A 3-in-1 consists of a rugged, waterproof outer shell paired with an insulated inner layer, usually a fleece or a synthetic puffer jacket.
And they connect.
Yeah, the inner layer zips directly into the inside of the shell. The appeal is pure versatility.
Because you can split them up.
Exactly. You wear the inner insulated layer by itself on a dry, chilly autumn day. You wear just the waterproof shell during a warm, humid summer rainstorm. Or you combine them both when you are facing freezing, wet winter conditions.
So it's basically a whole wardrobe in one item.
It provides year-round adaptability,
Yeah.
taking all the guesswork out of how to layer your clothing.
That's incredibly practical. And if these jackets are becoming so versatile, it makes me wonder how the technology is trickling down into everyday clothing.
Oh, it's changing everything.
Right. Looking at the 2026 market trends, we are moving way beyond just staying alive on a mountain. Here's where it gets really interesting.
Yeah?
We are seeing things like smart weather technology. We are talking about advanced fabrics that actively adapt to temperature and humidity changes. How does a piece of fabric actually do that without a battery?
It relies on innovations in material science, specifically something called shape memory polymers.
Shape memory polymers.
Yes. Traditional materials are static. They have a fixed structure. But these smart polymers have a dynamic physical response to moisture.
So they literally move.
They do. When the relative humidity increases inside your jacket because you are sweating, the structure of the polymer actually swells and shifts, physically opening up the microscopic pores to increase breathability.
Wait, really? It opens up on its own?
Completely autonomously. Then, as you stop moving, cool down, and the internal humidity drops, the polymer structure contracts and tightens back up to trap the warm air and retain your body heat.
That is a really clever way to handle it. It's effectively doing the work of the pit zips, but reacting directly to the microclimate on your skin.
Exactly. It's built right into the fiber.
Another massive shift in the 2026 gear space is sustainability. Because, for a long time, the outdoor industry relied on some pretty harsh, forever chemicals to make water roll-off jackets.
Yes, the environmental impact used to be pretty severe.
But now we are seeing a huge push toward recycled materials and eco-friendly coatings.
The shift away from PFAS, per and polyfluoroalkyl substances, is one of the most significant changes in outdoor manufacturing today.
Because they just stay in the environment forever, right?
Yes. Those old chemicals were incredibly effective at repelling water and oil, but they do not break down in the environment, which is terrible for the ecosystems we are trying to actually enjoy.
Yeah, that's deeply ironic.
The new eco-friendly coatings rely on entirely different chemistries, often mimicking the microscopic texture of a lotus leaf.
A lotus leaf, like the plant.
Yeah, they create surface tension that forces water to bead up and roll off without relying on any toxic compounds.
That's amazing. And alongside the tech and environmental shifts, the actual look of the gear is transforming.
Oh, drastically.
It used to be that if you wore a rain jacket, you looked like, a neon orange traffic cone.
Right. Very utilitarian.
But looking at brands pioneering the 2026 space, like Apparelizer, they are leaning hard into sleek, modern fits and neutral, muted color palettes. It's this whole blending of high-performance gear with urban style.
If we connect this to the bigger picture, the cultural shift toward gortcore and technically inspired fashion means consumers expect their clothing to perform multiple roles.
They want it all.
Exactly.
Yeah.
You want a jacket that can survive a sudden downpour on a rugged trail, but possesses the aesthetic appeal to be worn over a sweater during a rainy morning commute in the city.
Yeah, you don't want to look like you're climbing Everest to get a coffee.
Right. Brands like Apparelizer recognize that a highly technical rain jacket is no longer a specialized sporting good you hide in a closet until a camping trip. It is an everyday wardrobe essential.
Which brings up a very practical issue.
Okay.
If you are going to invest in a sleek, high-tech, smart jacket that you wear everywhere, you have to know how to maintain it. And I have a relatable confession to make.
Oh boy. Let's hear it.
For years, I just threw my old raincoats in the washing machine with my regular laundry, added a ton of regular detergent and fabric softener, and called it a day. Yeah. I didn't realize I was essentially destroying the jacket. Why exactly is fabric softener the mortal enemy of waterproof gear?
To understand the destruction, We have to revisit the microscopic pores in the breathable membrane we talked about earlier.
Okay.
Fabric softeners are essentially liquid synthetic waxes and chimic surfactants.
Waxes!
Yes, they are designed to coat the fibers of your regular clothes with a slippery residue to make them feel fluffy and reduce static.
Right, which is great for a t-shirt.
But when you wash a technical rain jacket with fabric softener, those waxes permanently lodge themselves right into the microscopic pores of the membrane.
Oh my God.
You physically plug the ventilation system. The jacket might still keep the rain out, but you have entirely destroyed its ability to let sweat vapor escape.
Wow. So I was literally creating the trash bag effect myself by clogging up the fabric.
Pretty much, yeah.
That is such a crucial thing to understand. And the guide says regular laundry detergent is almost as bad, right? Because it leaves residues meant to attract water.
Yes. Regular detergents often contain hydrophilic or water-attracting residues, optical brighteners, and perfumes.
And you don't want water attracted to a rain jacket.
Exactly.
Is-
If those get left behind on the outer shell of your jacket, they actually pull moisture into the fabric.
Yeah.
That is why it is imperative to use only gentle, technical detergents specifically formulated for outdoor clothing.
They just rinse clean away.
Right. They are designed to clean dirt and body oils without leaving any residue whatsoever behind.
And once it's clean, there's another step that people tend to forget, right? The DWR, or durable water repellent.
Yes, the DWR is that invisible chemical coating we discussed earlier, applied to the very outside layer of the jacket.
The lotus leaf stuff.
Exactly. Its entire purpose is to alter the surface tension so water beads up and rolls off rather than soaking into the nylon or polyester face fabric.
Right.
But over time, through abrasion from your backpack straps, exposure to dirt, and just general wear, that DWR coating degrades.
And when it degrades, the outside fabric basically acts like a sponge, right? It gets totally saturated and heavy. I've heard that referred to as wetting out.
Yes. When the outer fabric wets out, a continuous sheet of cold water sits directly against the breathable membrane.
That sounds miserable.
It is, because even if the membrane is clean and perfectly functional, your warm sweat vapor cannot push its way through a solid wall of cold water.
Ah, so you're trapped again.
Right. Condensation forms on the inside, and you feel wet, assuming the jacket is leaking when it's actually just your own trapped sweat.
So how do we fix it?
Washing your jacket with technical detergent and reapplying a fresh DWR spray restores that surface tension, allowing the